So today we are going to discuss the problems on bend, particularly the force whichever is acting on the tube or a pipe which is bented will be experiencing a momentum, and then it is going to be transfer or deviate its direction. On that time the force will be acting in the x as well as y direction. That resultant will be here like this. So this total force resultant will be calculated by using the total net force along x direction along y direction. Using that we are going to find the resultant. That resultant will be root of fx square plus fy square. Okay, so using this we do calculate this. Okay, so let us start with this. Here what we do is we are going to calculate the force exerted by the water on the bend. Okay, a 45-degree bend. Remember, the angle will mention in the horizontal direction. Everything is in horizontal direction. Don't consider this figure as the vertical manner like this. Okay, it will be the horizontal direction, but you consider it as you are looking from the top. So when you are looking from the top, it will be seen as like this. Okay, so consider it is a horizontal bend which is 45-degree from the direction of its previously flowing, is connected to a pipeline. The diameter at inlet and throat of the bend being 600 mm and 300 mm respectively. So here it was with 600 mm and it was reduced, even it is bented and it is reduced to 300 mm. It is something like a tapered bend, likewise we can say. Okay. Find the force exerted by water on the bend if the intensity of pressure at inlet to bend is 8.829 Newton per centimeter square. Okay, at inlet, so inlet means it will be P1, 8.829 Newton per centimeter square. The rate of flow of water is 600 liters per second. So I will write the given data one by one. So 45-degree bend, so theta is given as 45-degree. Diameter at inlet and outlet are 600 and 300 mm. So inlet diameter I will note it as D1, outlet diameter I will note it as D2. Similarly I am going to calculate A1, so which is pi D1 square by 4. So we are getting 0.2827 meter square, as substituting D is equals to 0.6. And similarly they have given the D2 is equals to 0.3 meter, and respective area A2 will be pi D square by 4, which is 0.07068 meter square. Now we got area as well as diameters, and we have noted the theta. Then what happened is the force exerted by the water on the bend is to be calculated, but it exerted the pressure. That pressure intensity at inlet is P1, that is 8.829 Newton per centimeter square. I am converting it into Newton per meter square, so just I am multiplying by 10 to the power 4. Okay, so it will be Newton per meter square, and discharge is given as 600 liters per second. Divide it by 1000 to get it into meter cube per second. Okay, because 1 meter cube is equals to 1000 liters. So if I want to convert liter into meter cube, means I need to divide it by 1000. Okay, so this is what we got Q. Actually we need to know P2. Okay, P2 is to be calculated, but the knowing of P2 is not simple, as the given data is seems to be irrelated to calculate P2. So what I do is I will apply Bernoulli's equation. So I will make it as two sections, 1 and 2. This is the inlet, this is the outlet, and I will apply the Bernoulli's equation. So what is Bernoulli's equation? P1 by rho g plus V1 square divided by 2g plus Z1 is equals to P2 by rho g plus V2 square divided by 2g plus Z2. As the pipe is horizontal, so Z1 is equals to Z2, it is going to be cancelled, and we left with P1 by rho g plus V1 square divided by 2g, P2 by rho g plus V2 square divided by 2g. This much we will have, but we don't know V1, right? But we can calculate V1 by using the formula Q is equals to A into V, where V is equals to Q by A. Q is given A1. If I want to know the V1, then I have to substitute A1. If I want to know the V2, I have to substitute A2. So I can get V1 and V2. So it is possible to calculate P2. So P2 can be calculated using Bernoulli's equation. So let us see. We are going to apply the Bernoulli's equation. So before going for that, we are going to calculate V1. V1 is equals to Q by A1. Q is 0.6, A1 is 0.2827. So we got V1 as 2.122 meter per second. As we have substituted meter cube per second divided by meter square, we will get the answer as meter per second. V2 is equals to Q divided by A2. Q is 0.6, A2 is 0.07068. So we got it as 8.488 meter per second, as we have substituted Q and A in terms of meter cube per second and meter square respectively. So we are getting V in terms of meter per second. Now we are applying Bernoulli's equation. So P1 by rho g plus V1 squared by 2g plus Z1 is equals to P2 by rho g plus V2 squared by 2g plus Z2. As horizontal, Z1 is equals to Z2. That's what I told you. The bend is in horizontal direction, not in the vertical manner. So what will happen if it is something like a road, it is running straight but it has taken the curve, that road will be in the horizontal direction deviation. Same thing is considered. Okay, your pipe is running straight but it has taken the deviation, but all are at same level. So Z1 is equals to Z2. So the term will become as P1 by rho g plus V1 squared divided by 2g plus equals to P2 by rho g plus V2 squared divided by 2g. So P1 is known 8.829 into 10 to the power 4. Rho is 1000 because water is running. G is 9.81. V1 is 2.122 square. V2 is 8.488 square. So P2 is unknown. I will write as it is. Rho is known, G is known, but here it is not required to substitute. Later we do substitution. And 2G is 2 into 9.81. 2 is 9.81. So substitute P1, V1 and V2. Already what we have calculated. Simplify it for its value calculation, and we got the first term as 9. This whole term upon simplification we got it as 9, and this term we got it as that term we got it as 0.2295, and P2 by rho g is unknown as it is, and 3.672. I'll send this to this side. So P2 by rho g will be on the unknown one side and values in the other side. So we are getting P2 by rho g is equals to 5.5575 meter of water. If I have to calculate P2, right? So P2 is equals to 5.5575 rho g. Rho is 1000, g is 9.81, and 5.45 into 10 to the power 4 Newton per meter square. This is how we got P2. Okay, using Bernoulli's equation, which unknown was found to us now. Yes. Now we are entering into the actual problem of bend. Okay, so if I want to know the force exerted by the water on the bend, I have to calculate the force along x direction as well as force along y direction. So to calculate force along x direction, we have the equation. Every student should remember this equation, and as we have seen in the derivation, that same equation you should remember, okay, which is Fx is equals to rho q into v1 minus v2 cos theta plus p1 a1 minus p2 a2 cos theta. Okay, you have to remember this equation for force along x direction. So the bend will be like this. That force whichever is acting in this direction, the net force in that y direction as well as x direction is to be calculated using this. That net force along x direction on the bend is given by rho q into v1 minus v2 cos theta. v1 is along x direction and v2 is along y direction. Sorry, v2 is along x direction at section 2. This is section 1, this is section 2. I will show you in the figure here. So here the section 1 is having the v1 along this direction and v2 along this direction. Okay, but actually I have to convert into this direction only, right? X direction I have to consider. This v2 is being taken as v2 cos theta. If this is taken as theta, then it will be taken as v2 cos theta, and this term will be taken as v2 sin theta. Here it is not required as it is running in the horizontal direction only. v1x will become v1 and v2x will become 0. Okay, so I hope it is understood to you. This component is being resolved, that's it. Sorry. So let us see next. Okay, so v1 is 2.122, v2 cos theta is 45. Okay, so rho is 1000, q is 0.6, v1 minus v2 cos theta plus p1 8.829 into 10 to the power 4, a1 0.2827 minus p2 5.45 into 10 to the power 4, a2 0.07068 cos 45, that is theta. Just we are substituting in this equation p1 a1, p2 a2, v1 v2 and rho q value as well as theta value. So upon substitution you do calculate. So 1000 into 0.6 into 2.122 minus 8.488 cos 45. We will get it as minus 2327.9. So don't worry about this minus or plus sign. You write as it is sign what you are getting. That is dependent on this theta value. So you need not to change anything. You write as it is value what you are getting in the calculation. Next part is 8.829 into 10 to the power 4 into 0.2827. So we are getting it as 24,959.6 minus 5.45 into 10 to the power 4 into 0.07068 cos 45. So we are getting again it as the 2720.3. The minus sign will be as it is from the relation or the equation. So upon simplification we will get it as 19,911.4 Newton. Okay, so this is what Fx. Then Fy is given by this equation. This also important, you should remember. Okay, so Fy is equals to rho q into minus v2 sin theta minus p2a2 sin theta. This is because along y direction in the section 1 there is no any velocity components along y direction, but in the section 2 we have the velocity component. Okay, that is v2 sin theta. And similarly pressure components are considered p1 a1 and p2 a2. Okay, so here we have the p1 a1 term in the y direction. only we have the P2A2. So P2A2 sin theta. This formula also you should remember. It is important to calculate Fy. Okay. So rho is 1000, Q is 0.6 minus 8.488. This is what V2 value sin 45 minus P2 5.45 into 10 to the power 4, A2 0.7068 into sin 45. So substitute and calculate. We are getting the values are negative on both the side. So minus 3601.1 minus 2721.1. Take the sum of these two negative values. So we are getting it as minus 6322.2 Newton. Okay. So this is what Fy value. Now we got Fx value as well as the Fy value. We have to calculate the resultant force using the equation Fx, that resultant force is equals to square root of Fx square plus Fy square. That Fx value is 19,911.4 square plus Fy value is minus 6,322.2 square. So we are getting it as 20,890 Newton. So this is what the resultant. But at what direction it will act? That is the theta for the resultant. So theta for the resultant is calculated by the formula tan theta is equals to Fy by Fx. So Fy value we have, Fx we have, and calculate. Actually it is mod of Fy by Fx. So we are not considering any sign, either plus or minus. We do just take the number and we do calculate it. We are getting it as theta is equals to tan inverse of 0.3175, which is 17 degree 36 minute. Okay, this is what the theta value. So it is represented here, this Fx, this is Fy, and this is what the resultant, and this is the angle theta. Okay, so this is how we are going to calculate that resultant force or the force exerted by the water on the bent. Okay, in the beginning only I told you, when the two forces are acting at inlet and outlet of the bent, it will be resulting in the some inclined direction. So it is that resultant force Fr. Okay.